Hello, hello, hello. Today I'm talking about why you should not attempt to try to predict stock prices using AI or machine learning unless. And before we get to the unless, let me just show you something interesting that I found. So a while ago on the first page of Hacker News there was this article, fantastic stock price prediction with AI. And it actually came with the Jupyter notebook, so I thought, wow, cool. I want to have a look. Obviously, if someone publishes that, like, I can just plug in and predict my own stock prices and make billions of dollars. So I just got the Jupyter notebook, and here it is. Now, the first we can see is, okay, it's got a little bit of an introduction, and then typical Jupyter notebook, it imports a bunch of packages, including Keras for AI, and as the backend of Keras, TensorFlow. For those who are not familiar with it, it's basically a Python implementation of a AI system, and Keras is a wrapper around TensorFlow and Theano and some other AI platforms. And then it runs through a number of processing steps. First, it gets here a couple of interesting functions that do several processing steps like plotting and data collection. And then it goes straight into the AI. Now, I don't want to actually bore you too much with how the AI is implemented. You can probably look at it yourself later. But I want to really show you that I've been running it and the conclusions that we get from this, which are very interesting. So first of all, we apply the AI to predicting the prices of Microsoft stock, and the time frame is from 2012 to 2021, 1st of January. The original paper actually went from 2012 to 2017, but I extended a little bit just to make a point. So it's all the way to 2021. And then we run through a few steps. We've got the training, testing set. We just conditioned the data to do LSTM. Well, I don't want to talk about how to do machine learning here. You probably already know this if you have done this before and if you're interested in this. So you can just look at the code later. Okay, so let's have a look at what is actually being used. So the author of this code wrote a set of different recurring neural networks. One of them is called LSTM, long short-term memory. It's a specific type of neural network, or also called deep learning or AI, whatever you want to call it. And LSTM is specifically good for dealing with time series, and obviously financial data are generally time series, so it makes sense to have a look at LSTM. Then he also uses different techniques such as SPI-LSTM and GRU, which are just different types of recurring neural networks. And again, if you haven't done this before, don't concern yourself necessarily so much with type of neural networks are used here. The idea is mainly to look at, hey, there is someone using neural networks and what the implications of this should be. So when you download the code, you can then fit it. So in some sense, I needed to make a few small changes to the original code just to get it to run, which I have done. And you can see here it just ran through different iterations in the neural network and then calculated it. And then what is really important here, we see the results. So this orange line actually shows us the set of data that the neural network was trained on. So it basically used about 66 or 2/3 of the data set to get data to train on. And then the rest of the data set was basically your test set. So we use the data from the neural network that we train on, and then we apply it to a test set. And what you can actually see here is, if you look really hard enough, you can see an orange line and a green line, and it's overlaid, or there's another line here which is a blue line, which is the actual prediction line. And one of the things we can see very clearly is that the two are virtually identical. There is virtually no difference between those lines, and you can go, whoa, this is pretty amazing. This is really, really excellent prediction of stock prices. And yeah, I was thinking that too. Initially I thought, well, if I can do this, then there is no limits to what can be done here. Now the author then goes on and actually shows these other types of neural networks, the bi-LSTM and then a GRU, and it shows, hey, they are also incredibly good in predicting prices. Now, when usually I work with financial backtests and financial predictions, one thing that is always served me very well is the good old mantra: when things look too good to be true, they usually are too good to be true. And so I saw this and I thought, wow, this is way too good to be true. And I thought, okay, let me just have a look into what is actually happening here. And so what I did is, and you can see this in the second part of my notebook, I call this the addendum, and I actually put my own little analysis onto this just to see what's going on. And so the first thing I did is, instead of the prices or predicting the prices, what I did is I looked at the returns. And so I thought, okay, obviously he's predicting prices here, but what about the returns? Because predicting prices really doesn't necessarily help very much, because let's say you're at $100. If you predict that the price is, say, 101 and the price goes to 99, you lost money if you go short. Or if you predict 99 and you go short and then the price goes to 101, you're also losing money. So in a way, predicting prices, yes, of course, when you're at 100 and you predict 101 or 99, you're still almost, you're pretty close to the actual price. There's not much of a change, there's 1% in your prediction. But in terms of trading, you actually make a huge mistake, because if you predict the wrong direction, then it doesn't really help you. You're actually losing. So it's the difference between winning or losing. So we really need to look, rather than at the price prediction, at the prediction of the directions. And so that's what I've done here, is I turned all this into the prediction of directions, or so to say percentage returns, and this is what I've got. So I overlaid the predicted prices with the predicted returns with the original returns. And you see here the two curves are quite different. But that doesn't really tell us much. What's really interesting here is the next thing. And so what I did here is I then plotted the predicted returns against the original returns. And what you can see here is this red blob. And this red blob basically tells us, well, actually, we can't predict returns here. So who knows, there might be a tiny, tiny little relationship here, but your normal eye can't see anything. What you see, however, at the background there is a blue line. It's a diagonal blue line that goes straight through. And so what that blue line tells us is we basically related the returns and the predictions with a 2-day offset. So what we can see here is, if we apply a 2-day offset between returns and predictions, there's actually a perfect match. It's a perfect straight line. And what that tells us is that the LSTM, in fact, predicts the returns as they were 2 days ago perfectly. So we have a fantastic prediction of the history, but unfortunately that doesn't help us much. We want to predict the future, right? And so when you look at this, the technique that was used here by the author, unfortunately, doesn't really cut it. We can really only predict the returns 2 days ago, but not the returns going forward. And we can see when we then take the return data from the predicted return data and compare them to the actual returns, there's a perfect match here. They're perfectly overlay. And so what the author did is effectively predict the past historical returns. Now, unfortunately, that is something I've seen in many of those AI papers or AI techniques where people say, oh, we can predict the price fantastically well. Look at this. This is like the ultimate in stock market predictiveness. But unfortunately, pretty much everything I've seen so far was very much along the same lines as what I've presented here. Unfortunately, not everyone is so kind and presents the code, so you can't really test whether they're actually true or not. The other thing is, I don't want to really knock down the authors of this. They've done their best, and to be honest, we all make mistakes, and specifically if you're a data scientist and you're new to this field of finance, then it's very easy to make this mistake. And this is really what I wanted to point out. It's not about, hey, the author's done something wrong. That's not what it is. It's about, hey, you're using complex tools without actually understanding the underlying processes and what's really happening. And that can really come to get you very easily. So here are my own conclusions of this. First of all, double check your results. Make absolutely sure that what you're predicting there makes any sense. Because if you're not careful, it could just be complete garbage. And then the second one is also really important. Never predict prices. They will always be close to the previous day. So when you predict prices, they will always look kind of perfect. Especially if you run this in the long run, they will always look like you're actually doing something really amazing. So always predict returns. That's really important, because returns is really what tells you whether you win or lose money in a specific trade. And then the next thing is, when you apply AI to any domain, you really need to make sure you understand the domain you're working in. If you don't really understand it, then probably make sure you actually get us some domain-specific knowledge. And specifically finance is very tricky. There's a lot of things that can easily come and get you, and you can make some really gross mistakes in that field. And then finally, the last point is, don't use AI in finance unless you know what you're doing. So obviously, if you really apply this and you trade your mom's super fund with it, or whatever, your grandma's inheritance, you could quite easily just lose all your money very quickly. And that's actually really not such a good idea. I mean, if you build a system that recognizes faces from images or from movies, then that probably doesn't have such big repercussions. But if you actually apply this to your financial accounts, then that could be quite dangerous. So I would highly recommend, if you get into this, just make sure you really understand at first what you're doing and how it's done, and probably how professionals are doing it, or learn a lot about the underlying methods and conventions that are used, and then you have a much better chance of being successful in this. And as always, I wish you best of luck, and I hope I see you in the next video. Bye bye. So before you go, please don't forget to subscribe and smash the like button so we can get a bit more traction on YouTube. And also don't forget to check out our other YouTube videos, some of which are really quite interesting. We also have 2 courses in Udemy. One is a basic Python for traders and investors course, where you learn a lot of quantitative techniques combined with learning the right programming skills in Python that help you to get quantitative trading right. And the second course is on futures trading, and it's a very deep dive into the ins and outs of futures trading, including quantitative trading and some interesting strategies that you can use in the markets. I hope you enjoyed this video, and we will see you in the next video next time. Bye bye.